Alrighty, last section of pre-calc, we're going to do some conics here. The first thing you need to do to write the equation of a circle, which is this, x minus h squared plus y minus k squared equals r squared. We need to identify h, k, and r. So h, k is the center, so let's draw some crosshairs here and find the middle. Looks like that would be at 1, negative 3. So 1, negative 3 would be x minus 1 squared, and y minus negative 3, y minus negative 3 would be y plus 3. Then the radius from negative 3 to 0 would be 3, so 3 squared is 9. And you should probably just write it as 9. So this would be equals 9. Now, sometimes it throws people off because they see this minus sign right here, and they think, oh, x minus 1, x minus on the x-axis, when you subtract, you go left. And that's true, but in a function it's sort of backwards. The x minus 1 is going to move it right 1, and the y plus 3 is going to move it down 3. So right 1, down 3, there's the new center of your circle, and the radius is 3, so square that, you get 9. Complete the square to convert the equation. Okay, so to complete the square, you want to get your x's on one side, and I like to leave myself a little blank. Get your y's on one side, leave yourself a little blank, and get everything else on the other. So 12, and then since we're going to add, we're going to have to add two things here. You don't have to put the blanks there, but sometimes it just helps set you up. So we're going to turn this into a perfect square trinomial. We're going to do the same thing here, and then we'll deal with what comes on the other side in a sec. To do that, you need to take half of your b term, so half of 16 is 8, and then we're going to square it. 8 squared is 64. We're going to put a 64 right there. We're going to do the same thing right here. Half of 4 is 2. 2 squared is 4, so we're going to add a 4. Now you can't add 64 on the left side and not add it on the right side. Same thing with 4. So I'm just going to put that over there and say, now I can factor. If you factor that and you factor this, you will get perfect square binomials. So x squared plus 16x plus 64 factors to x. It's always going to be half this because we did it on purpose. Half of positive 16 is positive 8. So x plus 8 squared. Half of negative 4 will be negative 2. And then on the right side, 12 and 64 make 76, plus 4 more is 80. So now this is the standard form of the circle, and you should also be able to tell me that the center of the circle, the hk value, is negative 8, 2, because this thing is going to go left 8 and down, or I'm sorry, up 2, and then the radius, that's the radius squared, so the radius would be the square root of 80, which is just a little bit smaller than 9. Alright. Identify the major endpoints or the major and minor axis. So here, let's draw a grid because we're going to want to see this. So to graph an ellipse, you have to remember that first of all, the center of our ellipse is going to be 3, negative 1. 1, 2, 3, negative 1, because x minus h, y minus k. So there's the center, just like the other ones. But there are minor and major axes in ellipse. So first thing you need to do is decide what is the major axis. The way you tell is you look for the bigger number. This guy is always your a value when you write the equation of an ellipse. The bigger value determines the major axis. So if the denominator here is bigger than the denominator here, you know that this is the major axis, which means this ellipse is going to have the major axis along the x-axis. So it's going to look something like this. It's going to be flat, it's going to be squished vertically or stretched horizontally, depending on how you look at it. But on the x-axis, the major axis is going to be the square root of that, 3, 1, 2, 3 to the right, and 3 to the left. So the major axis is actually 6 units long. The square root of 9 is 3, so you go 3 right and 3 left. The minor axis is along the up and down vertical axis, so since this is 4, we're going to go up and down the square root of that, which is square root of 4 is 2. Now we have our ellipse, which looks like this. That's pretty terrible. Let's try that again. You know what? I got a tool. Let's use the tool. Right like that. Hey, that's better. Okay, so there's our ellipse, and it asks for the major and minor endpoints. So the major would be, let's see, 0, negative 1, and 1, 2, 3, 4, 5, 6, negative 1. The minor endpoints would be 1, 2, 3, 1, and 1, 2, 3, 1, 2, 3, 3, negative 3. So the major endpoints are the ends of the major axis, that's here and here, and the minor endpoints are on the end of the minor axis, which is above and below in this problem. And that's it for conics. Good luck on your final.